right, let's go ahead and review some things we've talked about in our last few lessons. Of course, you studied last night over these things. You've been studying your class notes and these last couple theorems and corollary and things of that nature. For instance, you have memorized that if you draw a line parallel to one side of a triangle, bisecting a second side of the triangle, that line will also, Chris? Bisect the third side of the triangle. You've also memorized that if you draw a line that joins the midpoints of two sides of a triangle, that line will both be parallel to the third side and half the third side. What do we call that line, class? The no-name line. The no-name line, because it's certainly not a median of the triangle. We said if you were to have three or more parallel lines drawn such that they cut off equal segments on one transversal, Quentin, then they will chopped up into equal pieces. So if three or more parallels cut off equal segments on one transversal, they cut off equal segments on another transversal. Well, we said that a quadrilateral having two and only two sides parallel, Kendall, is called a trapezoid. If with that trapezoid, what do we call those parallel sides, Genesis? And the non-parallel sides are the legs. Can the parallel sides, can the bases ever be equal, Ethan? Never. Because then it would be a parallelogram, not a trapezoid, because you'd have two sides equal and parallel. So the bases can never be equal. Can the legs ever be equal?
Yes.
Sometimes. If they are equal, what kind of trapezoid have we?
Isosceles trapezoid.
We would have an isosceles trapezoid. What calleth we any perpendicular between the bases, Audrey? An altitude. And if we were to join the midpoints of the legs of our trapezoid, we would have, Chris, the
legs.
The midpoints of the legs.
You would have no-name line.
No.
Median
of a trapezoid. In a triangle, if you join two midpoints, it's a no-name line. In a trapezoid, you join those two midpoints of the legs, it's the median. Some things we know about the median of a trapezoid. Give me one thing we know about the median, Chris.
Is parallel to the third side. It's parallel to the third side.
I think you're thinking of the no-name line in a triangle. What do we know about the median of a trapezoid?
Parallel to the bases.
It's parallel to both of the bases. What's another thing we know about the median of a trapezoid? Kendall? What is the median of a trapezoid equal to? Audrey? Help friend.
Isn't it equal to like the third side? It's one of the sides.
Not a trapezoid. Chris?
Half the one side plus half the other side.
So half the sum of the bases. Okay, we need to memorize that, class. What's the median of a trapezoid equal to?
Half the sum of the bases.
Half the sum of the bases. And then we said the median will do what to the diagonals that we could draw in our trapezoid? It'll bisect the diagonals. So a lot of things to be keeping up with. Let's take a look at your homework now. And we had an isosceles triangle, and Chris, for better or for worse, was given the liberty to name our triangle and describe it. He said go for a tall, skinny triangle. And what did you name the triangle again, Chris?
I'm pretty sure it's XAB, wasn't it?
Yeah.
That sounds from the XAB. Okay. And it was isosceles, so we had as our given that we had isosceles triangle XAB with BX equal to BA. And then we were also given midpoints. We were given the midpoint of AX, which I think you called M, and we were given the midpoint of AB, which we called L? S. And then the midpoint of this side we called, that was the L, correct? I just remember MLS being Major League Soccer, and that's sticking in my head. But it was MSL, if you were to go in that order. So given isosceles triangle XAB with BX equal to AB, and then M, S, and L are midputs of XA, AB, and BX respectively. And was that all that was in the given?
Correct.
Okay. And we were trying to prove that if we drew lines from the midpoint of the base of any isosceles triangle to the midpoint of its midpoints of its legs, that we would form class a rhombus. So we were trying to prove that MSBL is a rhombus. All right, so of course your first statement would just be a recopying of the given. Of course, your first reason would just be given. There is some clang here. You've got a triangle with two equal sides. Clang. Equal angles. Which angles equal, Ethan?
Angle X, angle A.
Angle X and angle A are equal. Now, we didn't actually need that, but you don't know that starting out. So just, hey, get your clang statements right. What was your reason then, Ethan?
Angles opposite equal sides of
Good.
triangle are equal.
Angles opposite equal sides in a triangle are equal. I also have some clang from what? Quentin?
XM is equal to MA.
Also.
And XL is equal to AS.
XL is equal to AS.
Oh, LB.
LB.
And then AS is equal to BS.
Now here's the thought. Because we've got two parts of this and two parts of this, and these are equal, might it not be better, instead of saying these two are equal, these two are equal, these two are equal, to say that these are equal halves of their whole lines? Because then you could say that halves of equals are equal. So that might be something beneficial for us. I don't think it matters in this proof, but we could say that XA and AM are equal halves of XM and AM are equal halves of XA. We could say that XL and LB are equal halves of XB, and that AS and SB are equal halves of AB. The reason, Quentin? Definition of midpoint. Now, I will say this, it's a lot quicker just to say XM equals AM, XL equals LB, AS equals SB, right? It's quicker to say that. I've just got this feeling like it may help to have equal halves, because since we were given BX and AB equal, halves of equals class are equal. So I've got to follow that. If I'm just pure clanging here, I might say that XL equals LB equals AS equals SB, because, what again? There we go, halves of equals are equal. So rather than these two equal, those two equal, and those two equal, these two equal, and all of these equal. Does that make sense? Any other clangage? Well, isosceles, we already had equal sides, and isosceles, we already got our equal angles.
And we already did midpoints.
We already got midpoints. I think that's all the clanginess we have
That's
here.
all the clangage.
All right, now let's think about this for a minute. I'm trying to prove that I have a rhombus. What would it mean to have a rhombus? Two adjacent sides equal of a parallelogram. So first and foremost, this thing has got to be a parallelogram. What are some ways to prove something's a parallelogram? Jamie, give me one way.
Prove that two sides are parallel.
Not just prove two sides, two pairs of sides.
Okay.
Prove both pairs of sides. So if sides are parallel, we would have a parallelogram. What's another way? Genesis?
Opposite angles are equal.
Okay, if opposite angles are equal, that is if B and M, or let's call these 1, 2, and 3. If B and 2 were equal, and if, let's call these 4, 5, 6, 7, if 5 and 6 are equal, opposite angles equal, parallelogram. Audrey?
Opposite sides equal.
opposite sides equal. So these two equal and those two equal. Now we know these two are equal, but to be a parallelogram, I need these two equal and those two equal. Another way, Chris. Diagonals bisect, right? Do I really want to draw diagonals here? Probably not. I'm leaning toward let's not do that. But it's the method that we needed there. There is one more way to prove it's a parallelogram, Ethan.
No, I know.
Oh, so that was you taking the hand down. Okay.
I already saw another way to do it.
Okay. Quentin. You remember the last way to prove something's a parallelogram? Kendall?
Opposite sides equal and parallel.
Just two sides equal and parallel.
I know what we can do.
Huh. So I need to get those equal, or those equal, or those equal and those equal, or these parallel and those parallel, or maybe these equal and parallel, or those equal. Ethan?
Angles, we get angles equal.
What angles?
4 and 5 and then 6 and 7.
How?
Angles 4 and 5 is a straight angle, and angle 6 and 7 is a straight angle, and all straight angles are equal. So if they have opposite angles equal.
Wait, say that one more time. You said this is a straight angle at L, 4 and 5 together, straight angle. 6 and 7 together, straight angle. Okay.
All straight angles are equal.
Right.
So angle 4 equals angle 6.
How does,
Or angle 5 equals angle 7. So
which two angles are you saying are equal?
angle 5 and 6 really.
5 and 6 we want to be equal, right? But in order to do that, we have to subtract 4 and 7 away. Are 4 and 7 equal?
They can be if we do, if we get them congruent.
Oh, so you're saying if we got these two bottom triangles congruent.
They are.
They are? How?
On angle side.
Ah. Side, angle, or excuse me, sides, and in between them, angles. So yeah, we could state that triangle XLM is congruent to triangle. By the way, this is not the only way to do it if you did it differently. What?
MSA.
Let's see, what corresponds to X? ASM. There we go. You said side equals side, which is correct. And therefore, you said that angles 4 and 7 are equal? And since 4 and 7 are equal by CPCTE, then we could do for number 7, we could say that angle 4 plus angle 5 equal a straight angle, right? And what's the reason there? Also angle 6 plus angle 7 equals straight angle. How about the sum of all the angles about a point on one side of a straight line equals a straight angle? Informal statement 10. And because all straight angles are equal, you said, number 8, we could say that angle 4 plus angle 5 equals angle 6 plus angle 7, because all straight angles are equal. This is the Ethan show. And we'll subtract away the 4 and 7, so number 9, you said that angle 5 equals angle 6 by subtraction axiom. Right? All right.
Opposite angles equal now.
So 5 and 6 are equal.
It's a parallelogram now, right?
Well, I need not just these angles to be equal, I also would need B and 2 to be equal. How to get B and 2 equal? No thoughts. This is bad.
I thought that. Once the opposite angles are equal, those two are equal.
Yeah, but no, I need B and 2 to be equal as well. Otherwise, this whole thing kind of implodes. Well, let's think this. What if instead of getting the angles equal, what if we said, okay, well that method didn't work. Okay, so We take all the angles off, but maybe those congruent triangles in the bottom can still help me. Anyone else do it maybe without the angles, but use the congruent triangles? All right, Chris has a hand up.
I got sides equal.
Okay, which sides?
I got sides M and L equal.
ML and
MS.
MS equal by,
I got them equal by getting the triangles congruent using side, side, side.
ooh, whoa, whoa.
Side angle.
You can't do side, 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 or else they would already be equal to each other.
Yeah, that's the I got it congruent, then I said that they're equal.
No. To use side, 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 these all would already be equal, in which case you don't need the triangles congruent to get them equal. But I would say with what Ethan said, side angle side gets the triangles congruent, and then LM equals SM by CPCTE. Okay, so here's the interesting thing, class. I've got these two sides up here equal, and these two sides down here equal. Does that make it a parallelogram?
No.
Parallelogram?
No.
No. There's got to be a way to get those two equal. Because knowing these two are equal is good, right? I mean, I need adjacent sides equal to have a rhombus, but it has to be a parallelogram first. So I also need those equal and those equal. Or maybe these parallel and those parallel.
I have an idea, but it's going to be really tedious if we were doing y'all and anybody for wanting to say this.
So let's not do that then. We don't need hate in this class. Did anyone do it without getting triangles congruent?
That's what I did.
Everybody went congruent triangles? Okay. Then those who haven't pitched in, maybe, is there a way to use congruent triangles here? Because so far we keep coming up empty. Audrey? Uh-oh. Quentin?
Since MS and L are bisectors.
MS and L? Oh, the points are midpoints, right?
Oh, yeah. Okay.
Wouldn't MS be equal to SA?
I'm sorry?
MS would be equal to SA, wouldn't it?
Why would these be equal?
SA be equal?
He says that SM and SA are equal. Why would they be equal? Audrey has an idea now. Audrey?
Can you do substitution for the equal halves that we did earlier?
We already did here. What's your thought, Audrey?
I was thinking of getting two other sides equal.
Which two sides?
MS and like BL maybe.
MS and BL, right. So, right, if we could get those sides, because we've already got them equal, right? If we could get them, if we have these two equal. If we could get these two equal, then yeah, I mean, we've got equal lines, we could do the same there. Then we have parallelogram, so then we have rhombus by definition. We just gotta get this parallelogram. So, what was your thought?
Does it have something to do with the midpoint?
Well, it must, because otherwise midpoints wouldn't be a major part of the given, right? So the midpoints have to be important, and we've already used midpoints extensively, though there may be something more than midpoints we haven't considered. I don't know. I do know. Quentin?
MS would be equal to SA because S is a bisector of BA.
Right.
And M is a bisector of SA.
So because this point bisects this line, and this point bisects this line, it's got to be equal to that? There's a midpoint. There's a midpoint. This has to equal that? No. So just because two lines are being bisected and you join even in a triangle, that's not going to be true. Though we are, I guess, in a way trying to prove that in an isosceles triangle that'd be true, where of course this isn't an isosceles triangle. But maybe that helps some of you to see something?
No.
Chris?
If we go back to where like we had the ways to prove two lines equal, didn't we have that? Like there's different ways to prove two lines equal.
We did. I don't know that that's going to help us
It
here.
wouldn't help us.
Not as much as this might.
The no-name line.
Oh, a no-name line? Would this be a no-name line, class?
Yes.
Yes.
It would be a no-name line. Because it joins the midpoints of two sides. Would this be a no-name line?
Yes.
What do we know about a no-name line, class?
Equal to half of the third side.
Half the third side and
Parallel.
parallel to the third side. So,
They're not parallel to the third side. Are they?
so since MS is a no-name line, then MS is equal to half of AXB, and MS is parallel to XB. And since LM is a no-name line, class, it's equal to half of AB or BA, and LM is parallel to AB. Because the line joining the midpoints of two sides of a triangle equals half the third side and is parallel to the third side. Now then, these two lines are parallel. These two lines are parallel. What is this thing?
The parallelogram.
Parallelogram.
So it's one by definition.
MSBL is a parallelogram based on the definition of a parallelogram. And since we have two sides equal to each other,
The rhombus.
it's a rhombus. Based on the definition of a rhombus. The key to the proof, you could not complete the proof if you didn't use the fact that these were no-name lines. Which is why we've done two proofs yesterday that involved no-name line in hopes that when you got to the homework proof, you would think of the no-name line. Nobody did.
Now I do.
But you will next time, won't you? All right. Class notes section of your notebook. Class notes section of your notebook. We talked a lot about the median of a trapezoid, but there's a group of trapezoids that we've defined and then kind of left them alone. Surely there's got to be something special to the isosceles trapezoid, right? I mean, it's got two equal legs. Surely that does something, and it does. So we're going to talk a little bit about the isosceles trapezoid today. First thing on your class notes, brand new page if you would. Go and write this statement. The angles at either base of an isosceles trapezoid, brand new paper, in your class notes section. The angles at either base of an isosceles trapezoid are equal. The angles at either base of an isosceles trapezoid are equal. If you would, go ahead and draw to the best of your ability an isosceles trapezoid. Easier said than done, I know. I like to draw a line, draw a couple lines coming down that look kind of equalish to each other, and then draw a line across connecting them. Let's call it ABCD. And we are given isosceles trapezoid, ABCD. We want to prove that the angles at either base are equal, meaning this. At base AB, the angles there are equal, meaning angle A and angle B are equal. And the angles at the other base, CD, are equal. So angle C and angle D are equal. These are not all equal, just equal in pairs. These two equal, those two equal. That's what we're going to try to prove. Once you have that down, two columns, statements, reasons. Two columns, statements, reasons. Go and get down your first statement and your first reason. Clang, clang. Isosceles trapezoid, what does that mean?
Two equal sides.
Two equal legs, specifically AD and BC are equal based on the definition of Isosceles Trapezoid. But that's not the only claim that two legs are equal. What else is claimed?
Angles.
Mm-mm. It's a trapezoid.
Angle A will equal angle B.
AB is parallel to BC.
AB is parallel to CD. Reason? How many we got two parallel bases?
Definition of a trapezoid.
Definition of a trapezoid. So because it's a trapezoid, two parallel lines. Because it's an isosceles trapezoid, also two equal lines, but they're the other ones. Now, I heard it. Mr. Dasky, these two angles have to be equal because they're opposite equal sides. No. Angles opposite equal sides in a triangle are equal. That ain't in a triangle.
What if we form triangles?
Isn't that what we're proving?
We're trying to prove the angles are equal, but it's not quite that easy.
What if we form triangles?
Seems like it should be.
What if we form triangles? There's a thought. What triangles do you want to form, Ethan? ABD. So we draw a little diagonal here.
This is not gonna be good. Never mind.
Can you draw a midpoint?
A midpoint of what?
Midpoint of DC and midpoint AB.
So you locate the midpoint here, you locate the midpoint here, and then connect those. Do we have triangles now? But what if instead of trying to join midpoints, what if from a point we drew the one and only one perpendicular that may be drawn, and from this point we drew the one and only one perpendicular that may be drawn? That would give us a couple of triangles. In fact, it would give us a couple of right triangles. So let's draw those perpendiculars. Let's call these points X and Y. So number 4, let's say draw DX perpendicular to AB and CY perpendicular to AB, because from a point only one perpendicular may be drawn to a line. From a point only one perpendicular may be drawn to a line. Oh, guess what I just gave myself? Some more clang. Clang. So we got some right angles, right? Let's call these angles 1, 2, 3, and 4. And I know that angle 1, angle 2, angle 3, and angle 4 are right angles. Reason? Yeah, definition of perpendicular lines. So hey, by drawing a perpendicular, we gave ourselves some clang. Just a thought, something you might tuck away for future. Not sure what to do. Well, if I can draw a strategic perpendicular, I'll give myself some more clang at least. Maybe that'll help me. And if I've got right angles, I said that means we have
Equal angles?
Right triangle.
right triangles. Let's go ahead and state them, because specifically 1 and 4 are right angles, that triangle ADX and triangle BCY are right triangles. How do we know they're right triangles? Right, triangles with right angles in them, so definition of right triangle, we got right triangles. Now, how does it help me having these triangles? How does that help me to get angle A and B are equal, for instance? Should be pretty obvious.
Because they're right triangles, that means they're equal. No.
Because if these triangles were, for instance, congruent, then the angles would have to be equal by CPCT. And that's why drawing triangles is such a good strategy
They
here.
already are.
Are they congruent?
Yeah, because to prove a right triangle, all you need is side angle, right?
Oh, well, let's actually think. What are ways to prove right triangles congruent, Kendall? Sorry, misheard the wrong one. Leg, angle, hypotenuse, leg, hypotenuse, angle. What do we have so far already equal to each other, class? I'm sorry? What angles? Ooh, careful. By angle, we always mean acute angles. What I do have something, though. I got hypotenuses. So let's rule those out. Let's go with one of the hypotenuse methods. Okay, got a couple hypotenuses, hypoteni, equal to each other.
That's what I was wondering.
But I need some other things equal.
You need an angle.
Or a leg. An angle or a leg.
dx equals cy.
Why? They look equal, don't they?
Yeah, but we
Are they parallel, Audrey?
Aren't two perpendiculars drawn from the same, like,
I think what you're trying to say is that lines
perpendicular
perpendicular,
to parallel lines
lines perpendicular to the same line are parallel. Yeah, so I do know that dx is at least parallel to cy. Now that's not the same as saying it's equal, but dx is parallel to cy because lines perpendicular to the same line, I can't spell, same line are parallel. Now, Audrey, since they are then in fact parallel, does that mean they're equal? I have parallel lines included between parallel lines. Yes, they are equal. So that means number 8, that dx is equal to cy, because parallel lines included between parallel lines are equal. So Genesis, since, hey, these are equal, then my triangles are by, they're congruent by hypotenuse leg. Yeah. So number 9, I could say, Genesis, that triangle is congruent to triangle by, you said, hypotenuse leg. And since the triangles are congruent, class, angle A equals angle B by CPCTE. Now, I did hear one enthusiastic person saying that angle C and D were equal. Careful, I don't know that C and D are equal, but I at least know that this, call this angle 1 and this angle 2, those are equal, right? Angle 1 and angle 2, but that's not all of C and all of D. I need to get all of C equal to, or all of D equal to all of C.
Isn't dx cy square?
Not necessarily, but it is at least a rectangle if we stated that it was. I don't think it's going to help me as much, but if it is a rectangle, then Chris, we know that these two opposite angles are equal, and these two angles are equal.
If they're equal, then
But these are right angles, so they're equal to each other. So therefore, these are equal to each other. If you had an equals plus equals, the sums would be equal. That's a lot of steps.
but it's equal to you.
It does work. It does work. There's a quicker way. These two lines are parallel, correct? And this line could be called a transversal. I already know that this angle here is equal to this angle here. What do I know about A and all of D, since it's between parallel lines on the same side of a transversal? The two interior angles on the same side of a transversal of parallel lines will add up to a straight angle, or in other words, they are supplementary, correct? So I know number 11 that angle A and angle D are supplementary because the two interior angles on the same side of a transversal when parallel lines are cut by the transversal are supplementary. There's got to be a quicker way, easier way to say it. When two parallel lines are cut by a transversal, the two interior angles on the same side of the transversal are supplementary. Sorry, that's the only way to say it. You can look it up. I think it's like corollary 8.5 or something like that. Oh, here we go. Here's faster and easier. If two angles have their sides parallel, right side to left side and left side to right side, the angles are supplementary. You do that as well. So you got parallels, and because these are collinear technically, they're essentially parallel. They are in line with each other.
You said that after I already did.
Nah, no. But for that matter, if that's true of A and D, it's also true class of C and B. So angle B and angle C are supplementary, because if, when two parallel lines are cut by transversal, if two parallel lines are cut by transversal, the two interior angles on the same side of the transversal are supplementary. And so if A and D are supplementary and B and C are supplementary, but A and B are equal, not a substitution, these two are supplementary to equal angles. They are supplements of equal angles.
So they're supplementary to each other. No, that can't be.
This is why you've got to read through and skim through your notebook every couple of days. Supplements of equal angles are equal. Informal statement number 7 or 8 or something like that. Angle C equals angle D because supplements of equal angles are equal. Angle C equals angle D because supplements of equal angles are equal. So, isosceles trapezoid. Clang, parallel because it's trapezoid. Clang, equal. Definition of isosceles trapezoid. Clang, angles at the bases are equal because we proved it. Let's add another clang to the isosceles trapezoid. Turn the paper over. Unless you already went on to the back side. I don't think it was quite that long. Otherwise, new sheet of paper. We're going to write down this statement. The diagonals of an isosceles trapezoid are equal. The diagonals of an isosceles trapezoid are equal. Let's prove that this is true. The diagonals of an isosceles trapezoid are equal. What other figure did we talk about having equal diagonals? No, you can't draw diagonals in a triangle. Not parallelogram. Their diagonals bisect, but they're not equal. You have a long and a short. Nope. Square. Or more generally, rectangle. Rectangle has equal diagonals. We're going to prove an isosceles trapezoid does too. Go ahead and draw an isosceles trapezoid to the best of your ability. Don't look perfect, that's okay, we don't trust our eyes. Call it A, B, C, D. And go ahead and draw your two diagonals. AB and CA. And we're given isosceles trapezoid. A, B, C, D with diagonals AC and BD. We want to prove that those diagonals are equal. Prove that AC equals BD. Let's get that down. 2 columns, statements, reasons. It's just like fixing something in your house one day, guys. You're like, oh, I would fix it if only I had the correct tool. Wouldn't it be a shame if you had the correct tool all along, you just didn't know you had it? It's especially bad when you go out and buy the tool, and later you discover you already had it. Now you have 2 of the same thing, and you can't return the one because you already used it. The other one's already used too, so now you're stuck with 2 of this thing, and you feel like an idiot. All right, you got lots of tools in the toolbox. It's called your geometry notebook. That's your toolbox. Loaded with tools. But if you don't know what's in there, you can't use the tools. You've got to know what's in the toolbox, right? You got to have all these different thoughts memorized. All right, so we got our first statement, first reason. I'm trying to prove this line equals that line. Well, let's start with clang. That's a good place to start. Jamie, clang? That's the definition of isosceles trapezoid. A trapezoid with two equal legs. But you could write out, in an isosceles trapezoid, the two legs are equal. That's not a problem to write that out. Just, I'm lazy. Quicker to write definition of isosceles trapezoid. Also, playing. Kendall. AB's parallel to AC. Reason. Definition of a trapezoid. Trapezoid's quadrilateral with opposite two and only two sides parallel. Them's the two sides that are parallel. Definition of trapezoid. Also playing now, Ethan. And? Right, angle A equals angle B and angle C equals angle D, because we just proved, Ethan, that in an at each base. There we go. In an isosceles trapezoid, angles at each base are equal. Or you could say, if a trapezoid is isosceles, then the angles at the bottom base are equal to each other and the angles at the top base are equal to each other. It's not wrong. A little more wordy, but it works, right? So know that all of angle A is equal to all of angle B, and that all of angle D is equal to all of angle C. I think that's all the clang we got. Anyone else think of any more clangage? Here's all the clanginess I got. All right, let's think about what we're trying to prove. I'm trying to prove that line equals that line.
Rename the center and thank you. So what we call it? What we call like that's not like what is that center point called?
Nothing.
Nothing.
They don't got a name. It's just where the two lines have to intersect.
So if we could prove B.
We have two triangles congruent, right?
We have three triangles congruent?
Two.
I see 1, 2, 3, 4, 5, 6, 7, 8 triangles.
Well, I see one.
1, 2, 3, 4, 5, 6, 7,
Anyway.
8 triangles. Now, would any of those being congruent help me to get
ADM.
that line equal to that line?
ADM and BMC.
ADM and BMC? If they were congruent, then these two pieces would be equal, and those two pieces would be equal, and if equals are added to equals, the sums are equal, right? Now I already know that these two lines are equal, and vertical angles are equal.
So we have a leg, or we have a side and angle. And we also have half of an angle.
Oh no, where'd you get halves from?
Because the diagonal cuts B in half.
Oh no, it doesn't.
It's an I, it looks like it. Yeah.
In a rhombus it will. Well, forget those triangles then. Are there other triangles we could consider? Maybe if we go back to what I originally had and forget all about M's existence.
Maybe DAB and
I'm sorry?
DAB and
DAB. So this whole thing here, okay.
and then DCB.
DCB. This whole thing up here?
Yeah.
They sure don't look congruent. I mean, this one looks like an obtuse triangle. This one looks like an acute triangle. Also, if they were congruent, this line would equal itself. But I don't need this line to equal itself. I need it to equal AC. So, you're saying take Chris's first triangle, but use a collective bargaining agreement? Like that. So two overlapping triangles.
You already have one.
Okay, if these two triangles were congruent, then AC and BD would be corresponding parts. Okay, but let's unoverlap the triangles, right? Let's go off to the side, draw A, B, D, and off to the side, draw A, B, C. Okay, now we already know a couple sides are equal to each other already, right? Which two sides? Yeah, AD and CB were already given as equal in statement 2, okay? Also, Ethan already told us that the whole angle A equals the whole angle B, correct? Now, I don't know anything about this angle at B. This is, if we call these 1, 2, 3, 4, technically this is 1 and this is 3. I don't know anything about 1 and 3. But I know that the whole A and the whole B are equal.
We do know something about angle 1 and 3.
What about them?
Since line CB equals line AD, since it's the angle 1 and 3 are opposite, equal sides, they're equal.
Oh, you keep doing this, Chris. Angles opposite equal sides, class, in a triangle. That's two different triangles. So note that.
AB equals AB.
Whoa!
BA.
AB equals BA by identity. So, thoughts? Somebody besides Ethan? 5. There we go, Kendall. Triangle bad is congruent to triangle ABC. Yeah, bad is congruent to ABC by, you said, side angle side. Oh. And if the triangles are congruent, class? AC equals BD by CPCTE. There we go. So now another claim to the isosceles trapezoid is diagonals are equal. So let's think about an isosceles trapezoid for a minute. What do we know about isosceles trapezoid? Clang. Bases are parallel. Clang. Angles at each base are equal. Clang. Diagonals are equal. Clang. Legs are equal. I think somebody already said it and I just haven't accounted for it. Yeah, legs are equal, bases are parallel, diagonals are equal, angles at either base are equal. Lots of stuff we know about isosceles trapezoid. Lots of stuff we know about the median of a trapezoid. And all of it's in class notes. So make sure you study class notes. All right, homework for this evening is to study pages 98 to 102. Now, as you study those pages, exercises that are bolded and asterisked are the things we've been doing in class notes. Okay, so as you're studying pages 98 to 102, or studying in your notebooks, take note of those bolded asterisked problems that went to your class notes section. In addition to studying pages 98 to 102, copy pages 103 to 106, your theorems and corollaries. Copy pages 103 to 106, your theorems and corollaries. Also, on page 103, there's a box that says classification of polygons. Put that in your class notes section. Copy the box on page 103, the classification box, page 103, into the class notes. So you're copying the theorems and corollaries from pages 103 to 106, and you're copying the classification box on page 103. But that's going into class notes. And of course, don't forget to study. You've had a lot of stuff I've given you the last few days. And a lot of stuff from the rest of the year that you need to keep up with too. Study, study, study.